specifically PCR, which is polymerase chain reaction, and gel electrophoresis. So PCR, polymerase chain reaction, is a method of creating large amounts of specific genes or other DNA sequences. And it is very efficient and useful when there is little substance to go off of. It is not as useful when there are very large amounts, because other conventional methods are much quicker at just multiplying it. So it can make billions of copies of a specific gene or DNA segment in a few hours, while it would take a couple of days to screen a clone from a DNA library and let it replicate with host cells. So the procedure involves a 3-step cycle to create chain reaction that produces an exponentially growing population of DNA molecules, and each of these steps involve rapid heating or cooling to denature certain fragments so that they can be copied. And here's an image showing this process. So at each of the steps in the cycle, it is denatured by, or recombined by either heating or cooling, and shows all of the nucleotides waiting to be created into new segments in each of the steps. So this process relies on a very heat-resistant or heat-stable DNA polymerase, which is isolated from prokaryotes living in hot springs. Yep. And this is in order to withstand the heat that denatures the actual DNA segment, so that it itself is not denatured in the process.
What is the denaturing doing? Like when you heat the DNA, what do you mean denature it? Is it like denaturing a protein, or is it?
It's allowing for other nucleotides it's allowing for more copies to be made of the specific trait.
Right, and I do agree that is correct. But what I'm asking is, just want to make sure everyone understands, when you denature DNA with heat, what are you really doing to it?
I would think it would be breaking the hydrogen bonds.
Yep. And then what does that do?
It causes it to separate into sides.
Yep, into the 2 individual strands. Because you have to open the book if you want to access the pages inside, so to speak.
So the other process that we mentioned is gel electrophoresis. It uses gel as a molecular sieve to separate nucleic acids by size, electrical charge, or other physical properties, but specifically size, which also relies on electrical charge. And the end result are these bands of specific DNA molecule that are all the same length. So the procedure is the sample of DNA molecules is placed in these wells, and I'll have a picture later, these wells inside of the gel and near one end, and this gel is bathed in aqueous solution, and it has electrodes on each end, and it has 2 glass slabs on each side. And the next step is to turn the current on, which causes the DNA fragments to start moving to one side, and the smaller the DNA fragment is, the faster it will move to one side, which allows it to pool in its like little bands of certain shape. So here's an image of gel electrophoresis, and this is the little pockets where the DNA is placed, and here is cathode and anode on each side. And so once it is turned on, the longer molecules will move slower towards one end, and the shorter molecules will move faster towards the end, allowing to pick a specific size of molecule that you like.
Why do they move through the liquid?
Because they are negatively charged, and so once it's turned on, they will be attracted to one side, but some of them move faster than the other.
Where's the negative charge at?
The negative charge of
on the DNA molecule that's being attracted to the positive pole. Where is it predominantly negative?
Sure.
Okay, does anyone know? The negative charges on DNA, where would you expect to find them? What functional group has a lot of oxygen? Phosphate, yes, that's right.
So, what part of the DNA? The bonds
Where do you find the phosphate groups on DNA?
on the backbone?
On the backbone. Remember, the phosphates attached to the fifth carbon on the deoxyribose sugar. With phosphodiester bonds, you link the nucleotides together to make the polynucleotide. So there's a lot of phosphate there, and that negatively charged DNA is attracted to that positive pole.
That's it.
I have a question.
Yeah.
How big is like that?
Size, it can vary, but it's generally not very large because of how small the DNA itself is, so it doesn't have to be much larger than, say, this.
Yeah, so how do they like get the certain DNA